Hello and welcome to Tom and Sukey's Wood Shop. Today we're going to build this rather large panel gauge, and we'll go through all the design considerations of it and a little bit of history of it before we get started. So if you like our content, please like, comment, and subscribe. Thank you. Okay, so the panel gauge we're talking about, this is my old one and this is what we're going to be replacing, and I'll be taking this one apart for parts shortly, but I wanted to show it to you. And a panel gauge is just really a larger version of your garden variety marking gauge. This is the one I've had since I was about 7 years old, and it's still working. This one, of course, was made right after we moved. When we moved, I didn't have any room to move anything large. We were out of room. So I slapped this thing together, and rather quickly, with not everything I needed. And it's pretty sloppy, and it's got enough slop in it that creates, when it's all the way out, it creates, I don't know, probably 1/8 of an inch of play in the line. And it's not acceptable, and it's gotten worse over time. And we work on a lot of really large stuff like countertops, butcher blocks. And this thing only goes out to, I think, about 19, 20 inches. So it's just not big enough. So I wanted to make a new one that could do all of my larger panel gauge duties. This is my smaller one, but I only use it for up to 9, 10 inches just for resawing boards. So this is my marking gauge that I've had since I was a kid. And I have a bunch more of these, and I've made them. And the ones you make yourself, they always seem to slop out and different things. And I kind of struggled to come up with a design that wouldn't get sloppy. And what I came up with ultimately was this asymmetric design. It's kind of forces you to cut it in a little bit different way. And when you make it, you cut this hole a little bit small, and then you do most of your paring off this surface and this surface, and it keeps it a lot tighter. And also it doesn't seem to wear. This one is kind of also has an asymmetric, though it's rounded, it was obviously made with a machine, has a radius surface here and here, and that also seems to have held up better, and it has very little slop when it's tightened. So I kind of took all those things together, plus a couple of other little things I'd seen in other marking gauges, and I used a larger asymmetric shaft. That's what this is called here. And also on my fence, I have kind of a sub fence so that when you're riding along something, you can ride it in there, and then you can kind of raise and lower if you want to make a dotted line, or you can just hold it. You can also rock it slightly if you want to change the direction of the lead. And it can go all the way from a couple of inches, still a little tight, we haven't just finished it yesterday, go from about 1 inch all the way out to, let's see how far we can get this out here, to about there. So we can get out to about 42.5 inches. So that is enough to cut a sheet of plywood or mark a sheet of plywood if you needed to. And we actually, from time to time, do butcher blocks that are wider than that. So sometimes we need to mark stuff pretty wide. Okay. Well, here we are, and we tried some other things, and we couldn't quite get the shot we wanted. So white piece of paper it is. Sometimes cameras just don't see things the same way we do. So let's say I've taken my measurement, and this is the distance I want to be from the edge of the board to this. So I run my fence along this, and it just easily allows me to draw a straight line, just like that. Now the paper will show, that should show up really well for it. Demonstrating here how it works on the side of the board. Compared to a lot of other ones I've seen, this is a pretty good design. Okay, the other couple of big changes I made, and I do this in all my marking gauges now, is I've used threaded inserts at both the point where I put the pencil in. And this is a round construction pencil. It's 3/8 imperial. I don't know what it would be. An equivalent is in metric. And these are both 3/8 in diameter thread inserts, and they facilitate a 1/4 by 20 thumb screw. They're identical. And I put them in anything I build now that requires a fence like this. It works really well. I know there are, if you're not in the United States or Britain, there are metric equivalents of this too. So kind of find a close one. I think that's going to be 14 or 15, no, 10 millimeter, around a 10 millimeter insert. But don't get me lying, metric isn't my strong suit. Okay, so with that, let's get on to the build.
Here are the main components: the beam, the fence shoulder, 2 thumb screws, and a pencil and thread inserts for both thumb screws. Okay, in the original marking gauge, we determined that the angle at the top, shown here on the lower right, was a 60-degree angle, and the bottom angle was about a 30, so more or less. It doesn't have to be exact, but we found that approximately a 60-degree angle at that top profile or the top surface of the beam going down to the bottom face makes a good tight fit when we're making the beam go through the fence, rather than just having it square. So now he's just marking where he needs to plane down onto that edge at the bottom. Plane down along the entire length of the beam to make that profile. Be cognizant and aware of the marked lines so you don't get past it. And at first you can be a little more aggressive, and at the end it's a bit of finessing to actually make it even pretty much the entire length of the beam. Here you can see that Tom is getting very close to the finished profile. On the far end away from the camera, Tom decided to grab his scrub pane to get most of the initial waste off, and then he'll go back and refine it with his jack plane and maybe a smoothing plane. For the final smoothing, Tom uses his scraper blade to get this really flat, because you do want to make this pretty exact and pretty perfect. And so he kept testing it and looking at it down low with his eye to get it as smooth as possible at this point. Next, Tom clamps the fence and the fence shoulder together and marks the grain so that it's in the right direction, or they're both in the right direction, and the V on top that he briefly showed there was just an indexing line so that he can get these perfectly lined up when he goes to glue them. And right now he's finding the center. And if you're confused about which faces he is marking, I've provided the drawing at the upper right to show that he is marking the center of the top face of the fence shoulder, and then down the center of the face. That's sort of the business end of the fence shoulder, where the profile of the beam is going to be cut out to allow the beam to pass through. And of course, that's the whole point of the gauge, so that it is adjustable to the size panel you want to mark for later cutting. Next, Tom is going to make sure that the top of the cutout for the beam is below the distance that the thread insert would take up. And you can see that in the right-hand part of the drawing at the upper right. And that's so that your thumb screw can go through all the way to secure the beam, but your thread insert, won't go to the very bottom or top of the hole because that would scratch the beam. So that's just a little careful measurement you want to make, depending on the size thread insert you're using and how big your beam is, etc. Next, Tom is lining up the beam to that mark that he just made, and he's scribing the outline of the beam because that's going to have to be cut out from this shoulder of the fence. Tom is enhancing these scribe lines with a knife, and that's just to make it easier to start cutting this profile out of the fence shoulder with the chisel. Initially, Tom does not cut all the way through. He cuts about a 1/4 inch depth into this, and then he will test the beam profile to make sure he's getting that profile pretty accurate to begin with. After determining that the 1/4 inch depth cut was working very well for the beam, he cut through the rest of the fence shoulder. The final adjusting will happen at the very end, and it will be along the length of the beam and not within the cuts themselves of the shoulder and the other part of the fence. Tom is drilling out the hole for the screw thread or the thread insert. And he'll put that thread insert later, but he's just doing the hole now, and that's so that he can make sure that everything's going to line up to the beam cutout. Next, Tom is going to glue the fence shoulder to the main part of the fence, and after the glue dries, he can then cut out the profile of the beam cut out into the main part of the fence. He puts the two pieces together, lining up the indexing lines, which is usually just kind of a V, because actually that's much more accurate than one line, because then you have two little lines to line up on, and then he's just going to clamp it. The glue has dried and the clamps have been removed. Tom is just checking for square, and he's going to smooth off that top surface of the fence and just get it as square as possible. It doesn't have to be perfect, actually. And then he's going to scrape it smooth. And this is because it is a nice tool, and you'll want to have a nice smooth finish on this when you're done. And he's chamfering the edges with the plane so there are no sharp edges to dig into your hands as you use this tool. And now Tom is just going to smooth off the ends, or both ends, of the fence. And that's just so it's all nice. Get some of the excess glue off, gets it square, and smooths it off nicely. Now he's put the fence upside down, and you'll notice that back edge, which is actually the edge of the fence that's going to face you, he's going to chamfer it with that large plane. And that's, again, it's just so that as he grabs it, there are no sharp edges to cut into his hands as he uses it. You can choose to do this or not do it, but I would recommend it. It's just much more comfortable that way. Now the inside edge he's not going to chamfer, because of course you want that to be a nice sharp edge on that inside, so that runs up against your panel quite nicely and runs also against your bench if you're having the panel line up with the edge of the bench. Tom is now just smoothing that off with a scraper just to refine that a little bit. And he's also refining that edge because you really want that surface to be quite sharp and quite level, because that sits on your panel. And the other edge, of course, runs up against the edge of your panel, and that makes for a much more accurate mark. Now it's time to cut out the remaining part of the beam profile in the main part of the fence. And this is a little easier because you can just go straight down from the previous cut through the shoulder part. He has a pilot hole drilled in the back, and he's already marked the profile edge there. And this is just, he's trying to get most of the waste out pretty quickly, and then he'll refine this chiseling cut. Now Tom is inserting the thread insert into the shoulder portion of the fence that was previously drilled out. Now, if you mismeasured here and it was a little bit too short and got into the hole, just don't put the thread insert all the way into the top. You can leave it stick out a little bit. And now he's just screwing up his 1/4x20 thread in there. And that's what stops the fence from moving once it's set. Of course, you'll have it backed off when you're adjusting it. Here's a little trick. Tom is coloring the inside of the cutout with pencil so that when he slides the beam through, he can see where the beam is getting marked with bits of graphite, and that way he can remove that from the beam, because that's obviously where the beam is getting stuck. It was making very subtle marks on the beam in various places, and I wasn't able to successfully capture that on film or even with just a photograph. The other trick, too, is to watch as you press the beam through your cutout. Where it's sticking, it's going to create very shiny spots because, of course, it's pressing and compressing the wood fibers down, and that's going to make them a little bit shiny. So you can also detect sticking there. Now, this whole process of adjusting the beam is actually quite tedious and took quite a long time, and I did not bother filming most of it. You just have to keep going back and forth and taking a little bit off at a time with your scraper. Don't try to do that with a plane because you'll take too much off. Because you see, it does fit through there. It's just tight, and you want it to be just a little bit smoother. As you use it, of course, with age, it will become smoother anyways. But get it as smooth as possible and spend the extra time just going back and forth, carefully seeing where it is sticking on which of the faces of the beam you have to remove excess material from with the scraper. Once that was all working well, it was time to drill the hole in the head of the beam for the pencil to go through, and then of course another hole along the vertical face of the beam for the thread insert, which is going to keep the pencil secure. And because it's a nice tool, we spent a lot of time on it, we're going to put some nice finish on it.
Okay, we're going to go ahead and attempt to film a demonstration of this. So in this case, this panel's squared up on this side, and I want to cut it to 16 inches width. So what I do is I just make my measurement to 16. And then I loosen up my gauge and I bring it on over to my line. And this guy is just still tight enough that it's a little bit of a trouble. And this is always like trying to find that one groove in the phonograph. Yeah. Come on. Come on, a little bit more. There we go. All right, now I've got it. And I check it right down the center of it. And then I just make my mark. And you gotta be careful when you get out to the end of the board, like I just did there. In this case, I think my bench played naughty with me. Yep, my bench did play naughty with me. Anyway, and you just bring it on down this way. And there you go. And you're ready to saw that line off.